Most mechanics charge $400 to replace your oxygen sensor, but this $15 trick can bring it back to life. I've tested this on sensors that looked completely dead, covered in black carbon buildup, and the results shocked me. Here's what's happening inside your engine right now. Your oxygen sensor sits in the exhaust stream, constantly measuring air-fuel ratios. When it's clean, your car runs perfectly with optimal fuel economy, smooth acceleration, and your catalytic converter stays protected. But look at this. Carbon buildup turns your sensor into a blind spot for your engine's computer. Bad readings mean wasted fuel, rough running, and check engine lights. Ignore it, and you'll face a $2,000 catalytic converter replacement. But here's the thing. Most dirty sensors can be saved for the cost of a fast food meal. I tested these methods on sensors that mechanics said were dead. This one looked hopeless. Completely black, throwing multiple codes. 20 minutes later, it was reading perfectly again. Hit subscribe right now because today I'm showing you 2 proven cleaning methods that work when they don't work, and the one mistake that destroys sensors permanently. This could save you hundreds. But cleaning doesn't always work. Some sensors are truly failed, and you'll waste time trying to revive them. That's why the first thing we need to figure out is whether your sensor is dirty or dead. Grab an OBD2 scanner. You can get one for $30 and it'll save you thousands over the years. This is the most important tool in your diagnostic arsenal. Start your engine, let it warm up, then check the oxygen sensor live data. A healthy sensor bounces between 0.1 and 0.9 volts constantly, like a heartbeat. It should be switching back and forth rapidly when the engine is running at normal operating temperature. Your sensor is cleanable if it's responding, but slowly, voltage readings are sluggish or stuck around 0.45 volts. You're getting fuel trim codes like P0171 or P0174. And the vehicle has under 100,000 miles on the sensor. Stop wasting time if there's no voltage response at all with flatline readings, heater circuit codes like P0135 or P0141. Physical damage or cracking visible on the sensor, or coolant contamination from head gasket issues. I learned this the hard way. Spent 2 hours trying to clean a sensor with a failed heater circuit. The voltage looked good after cleaning, but the heater resistance was infinite. Check engine light came back after 20 miles. Quick test here. Measure heater circuit resistance. Should be 2 to 14 ohms depending on your vehicle. Infinite resistance means the heater's dead, and cleaning won't help. You're looking at a replacement no matter what you do. Method 1. The gentle approach. Let's start with the safest method. Fuel additive cleaning. This works great for light carbon buildup and regular maintenance. It's not the fastest fix, but it's the gentlest on your engine. You need oxygen sensor safe fuel cleaner. My top picks are Chevron Techron Concentrate Plus for $12, Lucas Deep Clean for $15, Royal Purple Max Clean for $18, and BG 44K for $28, which is professional grade. Step 1. Wait until your tank is 1/4 full. Don't dilute it with a full tank of gas. Step 2. Pour the entire bottle into your fuel tank. Step 3. Fill up with premium fuel if possible. 91 octane or higher helps the cleaning process work more effectively. Step 4. Drive for 30 minutes, keeping RPMs between 2,000 and 3,000. Highway driving works perfectly for this. What's happening is the cleaner burns during combustion and passes over the sensor tip in the exhaust stream, dissolving carbon deposits gradually. Now here are your realistic expectations. This takes 2 to 3 fuel tanks to show real results. It's not magic, it's maintenance. Think of it like using mouthwash for your engine. You don't see immediate results, but over time it prevents bigger problems. I use this method every 15,000 miles on my daily driver. Fuel economy stays consistent, and I haven't replaced an oxygen sensor in 8 years. That's real-world proof that prevention works. This won't work for heavily clogged sensors that look like they've been dipped in tar. For those, you need something stronger, which brings us to Method 2. Method 2, the power treatment. When your sensor looks like this, completely black with heavy carbon deposits, gentle cleaning won't cut it. Time for the vacuum line method. This is more involved but incredibly effective for seriously clogged sensors. Critical warning here. This only works for upstream sensors, the one before your catalytic converter. Downstream sensors don't get enough direct exhaust flow for this method to be effective. What you'll need is carburetor cleaner or mass airflow sensor cleaner for $8 to $12, access to a vacuum hose on your intake manifold, a straw nozzle which comes with most cleaners, and 15 minutes of your time. Step 1. Find your vacuum source. Look for a small rubber hose connected to your intake manifold. Your best options are the brake booster line for easiest access, PCV valve hose, or evap purge valve line. Pick one that's easy to reach and about 1/4 inch diameter. Step 2. Set up the delivery system. Carefully disconnect the vacuum hose, insert the straw nozzle directly into the hose opening, reconnect so the straw stays secure. Attach your spray can to the exposed straw end. This creates a direct path for the cleaner to get sucked into the engine. Step 3. Warm up the engine. Start your car and let it reach normal operating temperature about 5 to 10 minutes. Hold RPMs around 2,000 to prevent stalling when you introduce the cleaner. You can do this by lightly pressing the gas pedal or having someone help you. Step 4. Apply the cleaner. With the engine at 2,000 revolutions per minute, spray short bursts, 1 to 2 seconds maximum, through the straw into the vacuum line. Wait 10 to 15 seconds between each burst. Repeat until you've used about half the can, roughly 10 to 12 sprays total. Never spray continuously. This will flood your engine, cause stalling, or damage internal components. Patience saves thousands here. I cannot stress this enough. Step 5. Burn it off. Rev the engine to 3,000 to 4,000 revolutions per minute several times. High heat burns away the loosened carbon stuck on your sensor. White smoke from the exhaust is completely normal. That's the cleaner burning off along with the carbon deposits. Step 6. Cool and reconnect. Turn off the engine and let it cool completely 10 to 15 minutes. Don't touch anything until it cools down. Reconnect your vacuum hose and check for leaks. Step 7. Test the results. Clear your check engine light using an OBD2 scanner. Drive for 15 to 20 minutes. If the light stays off and performance improves, you just saved $400. Here's proof this actually works. This sensor was throwing P0131 code, oxygen sensor circuit low voltage. Look at the carbon buildup. You can't even see the ceramic element underneath all that black coating. After using the vacuum line method, complete transformation. Carbon is gone. Ceramic element visible. Sensor tip clean and metallic. No scrubbing, no soaking overnight in chemicals, just the right cleaner and 15 minutes of time. Reinstalled it, cleared codes, drove 25 miles, check engine light stayed off, throttle response improved immediately. Fuel economy increased 14% over the next week. Total cost, $11 for the cleaner, but I need to be honest with you, this doesn't always work. Sometimes sensors are just done and no amount of cleaning will bring them back. I tested this on another sensor with code P0154, no activity detected. After cleaning, it initially worked. Voltage fluctuated normally like a healthy sensor should. 42 miles later, check engine light returned. Code P0171, system too lean, rough idle came back. The sensor wasn't just dirty, it was internally failing. The ceramic element was damaged from age and heat cycles. No amount of cleaning fixes broken ceramic elements or worn out wiring. The reality is this: if your check engine light returns within 50 to 100 miles after cleaning, stop wasting time. The sensor needs replacement, and continuing to clean it is just throwing good money after bad. The best time to clean your oxygen sensor is before it gets dirty. Prevention is always cheaper than repair. Here's your prevention strategy that actually works. Every 30,000 miles, replace spark plugs. Worn plugs are the #1 cause of sensor fouling. They create incomplete combustion, producing tons of carbon that coats your sensor and slowly kills it. Every oil change, add fuel system cleaner to your tank, $15 every 7,500 miles prevents $400 sensor replacements. It's the cheapest insurance policy you can buy for your engine. Watch for these early warnings. Decreasing fuel economy is usually the first sign. Rough, idle or hesitation, black exhaust smoke, and engine misfires are all red flags that something's going wrong. Here's what I call my $80 rule. When you notice symptoms, spend $80 on basic maintenance first. New spark plugs, clean air filter, fresh fuel filter. 9 times out of 10, this fixes the root cause and brings your sensor back to normal without any cleaning needed. Fuel quality matters more than most people realize. Always use top-tier gasoline, Chevron, Shell, Mobil, Costco. Higher detergent levels keep your system cleaner from the start. Cheap gas might save $2 per tank, but it causes faster carbon buildup. Pay a little more now. Avoid $400 repairs later. Let me save you time and frustration. Don't attempt cleaning if your sensor has over 100,000 to 150,000 miles. At that age, ceramic degradation is normal. Just replace it and move on. You're getting heater circuit codes like P0135, P0141, P0155, P0161. Cleaning won't fix electrical failures. These are internal wiring problems that require replacement. The sensor shows physical damage, cracks, melted plastic, or coolant contamination. No amount of cleaning fixes mechanical damage. Time value calculation here. If you've tried cleaning twice and the light keeps coming back, you spent 4 hours and $30 in cleaners. Just buy the $80 sensor and move on with your life. Getting multiple oxygen sensor codes on different banks? Check for exhaust leaks first. One leak can trigger false codes on several sensors, making you think they're all bad when they're actually fine. Here's your complete action plan. Test first using an OBD2 scanner to confirm the sensor is responding. Start gentle with the fuel additive method for light buildup. Go aggressive with the vacuum line method for heavy carbon deposits. Fix root causes by replacing worn spark plugs and using quality fuel. Know when to quit and replace sensors over 100,000 miles or with electrical faults. This simple maintenance can save you $400 on sensor replacement and $2,000 on catalytic converter damage. The math is pretty simple here. If this saved you money, smash that subscribe button and ring the notification bell. I post money-saving car maintenance tips every week that could save you thousands over the life of your vehicle. Drop a comment below. Have you tried cleaning your oxygen sensor? What were your results? Did it work? Or did you end up replacing it anyway? I read every comment and reply to as many as possible because I learned from your experiences too. Also, check out my video on car repair secrets that mechanics don't want you to know. These are the hidden tricks and shortcuts that can save you hundreds on common repairs that shops charge premium prices for. Link is in the card right now, and it's definitely worth watching if you want to avoid getting ripped off at the repair shop. Thanks for watching Car Care Simplified. Remember, knowledge is power, but applied knowledge is money in your pocket. The more you learn about maintaining your vehicle, the less you'll spend at the repair shop. Subscribe for more videos that put money back in your wallet, and I'll see you in the next one where we're talking about another common repair that you can do yourself for fraction of the cost.